Coming up on the FTC Open Alliance show, we're back for the Decode season with FTC Open Alliance founding team 12736 Electric Mayhem Green out of Buffalo, New York. 12736 has made some awesome early season progress. In addition to hearing a bit more on how teams can get involved with the FTC Open Alliance, we dive a bit more into their strategy and design methodology, Crayola CAD, 2 robot parking prototype, and vision tracking utilizing the Limelight 3A and the April tag. Let's jump right in and check on the progress on the FTC Open Alliance show. And we are back with the FTC Open Alliance show, and of course, one of our founding teams here who are really making it loud and had an awesome kickoff. It is 12736 Electric Mayhem Green. Everybody, welcome back. It's great to see you all again, and we got so much to cover here today. I can't wait to dive into more. So why don't you introduce yourselves, and let's hop right into what you've been working on since the Decode kickoff.
Yep. All right. So I'm Emily. I'm the green team captain, the 12736 green team captain.
I'm Josh. I'm one of the other captains for Green Team.
I'm Hamid. I'm a senior on the Green Team, and I'm also the head programmer for the FTC Open Alliance.
And I'm Nate. I'm a senior, and I write the book guns.
Should I start? All right, cool. So the first thing we're going to talk about is the FTC Open Alliance. So as I mentioned, I'm the lead developer for the FTC Open Alliance. It's something that me and Nate started for last season. So this is our second year of running the FTC Open Alliance. And essentially what it is, if you're familiar with the Open Alliance, which is the FRC version, it's pretty similar in terms of we share the ideal of teams being able to share what they're doing with their robot, their designs, all of that stuff, and being able to learn from each other, really embodying cooperation, gracious professionalism. So we wanted to bring that to FTC. So we made the FTC Open Alliance, which you can get to at ftcopenalliance.org. So this year we've actually got quite a few teams already on the roster. We've got, 12 teams? This is 11 teams. Yeah. So each of these teams has, their own page, like we can go to ours, where we list out all of our details for the robot that we're building, what kind of parts we're using and stuff like that. And then we also have a whole bunch of links to go to a build thread on Chief Delphi to share our CAD, our code base, photos, videos, and a website. All of this stuff can be shared by any team who wants to join, and it's available for all teams to come and view. All of this data is made public. So if you are a team who's looking to maybe, do more outreach or, try and get more into the community, a great way to do that is through the FTC Open Alliance, and you can register at ftcopenalliance.org/join. But if you're a team that just wants some inspiration or you want to see what other teams are doing, you can access the FTC Open Alliance at any time and read through the build threads, look at other stuff, look at CAD links. It's all open.
So, Hamid, what is a team like? What are kind of the requirements of a team if they want to be part of Open Alliance? Do they have to post so often or anything like that? Or what are kind of just some of the basics if they want to get involved in this?
So, all we really ask is that teams stick to the fundamental goals of the FTC Open Alliance. We don't want teams to be, keeping secrets or, saying information for, to bring down other teams. We want everything to be collaborative. We want everything to be open. That's the namesake of the program. And part of that is obviously just, sharing out what you want about your team and also, keeping up with developments in your team. So I think one of the strongest things that we suggest is that if you're a team, you make a build thread and you update it regularly with news about your team throughout the season.
Well, the Decode Challenge was just released this past weekend. Hopefully you guys are excited for it. So give me a little bit about your first impressions for it, and let's jump into how your team approached kickoff and some of the methodology behind it.
So this year we took a slightly different approach to kickoff than we usually do. We've been working with a creativity consultant. He's a parent of one of the members on our team, and he's helping us get more creative when we're coming into the problem-solving aspect of kickoff. And we're really trying to focus on divergent and convergent thinking. Divergent thinking being you try to get as many ideas down on paper as you can, even if it's the most outlandish idea that you think would never work. You want to write it down, and you want to delay your judgment when it comes to those sorts of ideas, because those sorts of ideas can often lead to interesting trains of thought, which could lead to a lot of more interesting ideas and stuff like that. After you diverge, you want to converge. Pick one of those ideas and really narrow in. So the way we did this at kickoff was we listed all of the questions we had about the game and all the aspects of the game that we could form a question around, like how do we pick up an artifact? Is a slingshot shooter viable, or do we want to do kind of like a baseball pitching machine shooter, stuff like that? And then we split up into groups, and we each picked one of those questions, and we tried to think of as many solutions and answers to those questions as possible. So like my group, we really focused in on how to do the end game pack. We came up with a lot of ideas like getting robots on top of robots, trying to get robots to wheelie so that you're only supported by that pack tile and stuff like that. And I came out of kickoff thinking that I had a much firmer grasp on the game, and I had a lot more ideas going into a Robot in 30 Hours challenge when it came to how to solve this year's challenge.
So can you talk to me just a little about your team did a Robot in 30 Hours challenge? What were maybe some of the biggest things you learned from that?
So this year, like last year, instead of trying to build a full robot in 30 hours, we tried to get as many prototypes down as we could. We focused really early on shooting and being able to auto aim and move while we shoot, along with having a super fast touch your own intake for the artifacts. And that kind of led us to main Crayola CAD. Which was the main thing that we got out of 30 Hours challenge. So this is what we got after the 30 hours. This was our main digital prototype. It's a over-the-top roller intake robot. It has these roller wheels here, which can articulate up and down to get in front of and then over and then behind the artifact when intaking it into the robot. Then we have these rollers up here, which help move it into a turret shooting system. And this turret we intend to put it on a turret, so that as we drive around the field, we can point a drivetrain wherever we want for intaking or just speedy driving, stuff like that, and have the turret always pointed at the target, so that no matter where we are on the field, we can shoot, and the robot will just figure out how to get that artifact into the net.
What's the chassis size look like for this?
What was that?
What's the chassis size look like?
So currently we're working with a 16 by 16 inch chassis. We're trying to keep the robot small, but small so that we can really effectively do that end game pack. But we're also examining wheelie pack concepts. That's what this thing is down here. It's a little kicker that will hopefully prop half of the wheels up on our robot. There's supposed to be one on this side. So that way only the back two wheels of a robot and this little kickstand is in the park zone. So the 16 by 16 is so that we can take up about half of that pack zone, which hopefully is enough room for our partner to get a full pack if they're a skinny or small robot, or a partial pack if they aren't, which from our calculations will probably still be enough to get the ranking point at the end of the match.
And then if I can ask from an intake standpoint on there, is the intake strictly those wheels that are right there? And if so, how wide is that intake? Like how much tolerance do you have in regards to the 5-inch ball coming in?
So we've been playing with a couple of different tolerances. We are trying to go for a width of between 6 and 7 inches. It kind of comes down to how wide bearing for the turret has to be. We haven't decided on a set bearing size just yet. But once we have that size, that will determine the size of the intake. But somewhere in the 6 to 7 inch range is kind of what we're working with. I believe this one is 6.5 currently.
So for your team, what are maybe some of the next, you got this initial Crayola CAD, what are kind of the next steps that your team is in regards to how they're approaching the Decode Challenge in general?
So this was just a 30 hours Crayola CAD. So we are looking to maybe get some aspects of this CAD in physical prototype. The intake and the shooter being focuses there. We want to get the shooter and the turret built physically, test wheel spacings and wheel types. It's just a compliant wheel for now, but we're not set on having that shooter wheel be an anti-mag compliant wheel. Testing intake heights, intake widths, really trying to narrow in on how big and what tolerances we need to play with for these systems.
Well, one of the things that you kind of alluded to a little bit was the parking methodology and right what you're looking at doing that. So I'm really excited. Why don't we go over to the field and take a look at what your team is looking at doing from parking? Because that's such a tough challenge, I think, that a lot of teams are very interested in learning more about.
Of course.
All right. So for parking, we have two different designs here, but the first one we're going to show is using constant force springs. And our idea is to drive halfway out of the box and lower basically T-slot below our robot using a spring that's released with our front wheels up off the ground and keep the back in the box so we're still fully supported by the box. And the second one we have here is using the egg-shaped thing.
Okay. There you go. Kind of solid jump there, but you get the point with constant power.
When it's at the right angle, the front is lifted off just like the T-slot, just a lot less, and it uses a motor instead of servos and springs.
Yeah, so the basis for this design is the strategy that Net was talking about earlier. So if you look at the park zone, they're an 18 by 18 inch square, and our ideal is that we only take about half of this, but still get a full park. And seeing as our robot is 16 by 16, it's kind of hard to get that in there. So what we decided is, looking at the rules, it said that we could do a fully supported is what the full park was. So we went for a design that would get our back wheels up and not have to extend up 18 inches to get another robot under us, so that we could get that full park and allow for another full park or a partial park from the other team just by sticking the wheel in the side. That allows for us to get the qualifier ranking point for parking, as well as the state one later on, which is 21 points.
So I want to ask you, you mentioned the ranking points. I think that's a really interesting thing this year, right? For FTC, is we're seeing that implementation of more and more ranking points. What are your initial reactions to the kind of the changes in how ranking points are being added even more this year?
That is, we're pretty happy about this. We're excited to have more chances for skill-based ranking points that aren't just coming from auto and just the winning the match. I think that it's a really fun addition to the game, having the incentive to build on your park and build on the motif scoring.
Very cool. These are great designs, and I look forward to seeing, going from that CorelliCAD into this, into even more prototypes for it, which I think are going to be really cool. I was watching your robot in 30 hours a little bit, and you were showcasing some more of that demonstrations on how you're looking at doing a turret, utilizing a Limelight 3A and the April tag and stuff. Can we jump a little bit more into how that's going to work and showcase that?
Yes, of course. So I'm going to bring up robot over here. Josh, could you get the driver station? So this is a Mechanum base that we just had before the start of the competition, and when during the 30 hours, we realized that we wanted a turret, and so we had a little Lazy Susan just laying around, and we tasked a couple of our members to attach it to here, so that we could test some of our Limelight April tagging, because that was one of our main concerns with making a turret, to see if we could get that to work. We do have a little demo here. This was showcased in 30 hours, as you said, and there's a couple shorts about it, but I don't know what the best way to do this. Give me. Yeah. Thank you, Nate. Okay. All right. So Nate's gonna just angle this at the April tag, and you can see if you just as it's turning, you can see the turret there turning with the limelight, and it's orienting itself. Obviously, this was done in just the 30 hours challenge, and we plan on building on the functionality of this. But you can see as he turns there, it's reorienting itself to look back at it. And we plan to use this so that we can go intake and easily reorient our shooter to be able to shoot in there as quick as possible. We're really proud of getting this working so fast into the season, because this will be a major help for getting our cycle time quicker later in the season.
Well, Electric Mayhem Green, this is a fantastic start. I think your team is off to. Before we let you go on this, anything else that you want to highlight or talk about, or maybe any other future next steps that you're looking at accomplishing very soon?
I'm not sure. So I think a lot of our next design steps that I've been thinking about is how we're going to get the actual shooter itself to work. I don't know if Josh, you want to talk about that. But I'm really excited. I was a little bit skeptical personally about the idea of having the spinning turret on the always spinning robot, but I was convinced, and I'm really excited to see how our team figures out how to get that to work, feeding through the center there. Thank you, Nate. Josh, I don't know if you want to make any remarks about your next shooter plans. You can also check on what we were doing with the shooter in our 30-hour stream. We have a bit of tests. I believe there's a YouTube short about it where we showcase just a test on the tolerances of shooting these blocks into here.
Yeah, and you can find them under Electric Mayhem Robotics on YouTube, so make sure you do check that out as well. We showed one of the shorts on screen just a little bit ago, too. So Electric Mayhem, thank you so much for taking the time to tell us more about this, and wish you best of luck the rest of the way. Make sure you are following their FTC Open Alliance blog that you'll be able to find both on Cheap Delphi and on the FTC Open Alliance website as well, too, at ftcopenalliance.org. Thanks a lot.
Thank you.
Thank you.